and welcome to stack.stream. Today I will share my experience of using the MongoDB Atlas search functionality. I will talk about how we can configure the search index in the MongoDB console and then how we can write a cloud function to provide the autocomplete capability that can be integrated with any app that has access to the internet. I was working on a project in which we were required to provide a type ahead autocomplete to search for, you can say, different places or different companies or businesses. So I was looking for various different backend databases that allowed me to store that information and also help me with the autocomplete search. So first I started looking at Firebase, but it looks like at the moment Firebase does not support full text search. Instead, they recommend using an external service, which, as you can see here, they are redirecting us to use either Elastic, Algolia, or something called TypeSense. But this would mean that we would have to work with another third-party search provider, which would increase the complexity of the code. I also found a video posted by Jeff Delaney of Fireship.io showing how to implement such functionality, but the solution does not look ideal, and even Jeff points out the drawbacks of that approach.
Where each key in that object is a string that gets progressively larger. That allows you to make queries where a certain document has a title that starts with W or WA or WAL and so on. Again, the cool thing about that is we don't need to use or pay for any third-party dependencies, but the drawback is that the user has to enter their search term correctly and it won't be robust to spelling errors and things like that. So this works best when your needs are simple. If you have really complex multi-property searching that you need to do, I would still recommend using something like Algolia.
Luckily for my use case, MongoDB does provide a full text search supporting autocomplete use case out of the box. This autocomplete feature was, I think, first released in the April of 2020, and MongoDB have continued to add more features to it since then. However, as you can see here, Atlas Search is only available for either shared plan, which is free, or for the dedicated plan, which currently costs $57 per month. So as you can see here, it is still in the works for the serverless option, and maybe a lot of startups might be interested in this once they have done their proof of concept or MVPs. I think the next step for them would be to move on to a serverless model naturally, but so far it's only on the shared and dedicated packages. So let's see it in action. Right, okay, I have logged on to my MongoDB account and I can browse to my collections. So this is my collection, and in order to create a search index, we have to go to the search indexes section, and then in here we will find this create index button. And it gives us a couple of options to create the index. I prefer the visual editor because I am new to MongoDB. So I am not aware of all the JSON syntax, but you will see that when we work with the visual editor, it will give you the JSON syntax. Let's give it a name and select our collection, then click on next, and then we can refine our index here. It provides you some default analyzers. So what I have learned is it's better to select a language if you are searching, which is based on your standard language words. So here we are working with English, so I'm going to find an analyzer for English. Here. And so here I'm going to add a field mapping, and it could be anything in your document. So in my case, I'm selecting the name, and I'm going to set it as a string, and then again in the analyzer I will select the English language analyzer. Let's just leave all the other fields as defaults and click on it. And you can also add an autocomplete field mapping for this field, because this is what we will be searching for. Yeah, I guess that should be all. I will click on save, and I will click on create search index. So the index takes a few minutes if we don't have a lot of data. I am going to pause the video and we'll resume recording once the index is completely built. As we can see, our index creation is completed. Let's test our index. And we can see that it has come back with some of the records, and it seems to be searching all of the fields that have Ajax in them. Let's try another word. So as we see here, it just did not search the name field. It also indexed the address. And let's have a look at the query syntax. So as we see here, it is searching, like this thing is telling it to query this particular text, and path means that it is trying to search for this text in all of the in the fields in all of the fields that we have in our document. So basically here we can narrow it down to only the field that we are interested in, but by default in this search tester, MongoDB has given a path, a wildcard of star here, so that it can look into all of the available fields. Now let's see if we give it a partial text, like something like this. So with this, as we can see, we are not seeing any results. This is because we are missing the autocomplete syntax, and I'll show you how that works. Let's try the same code in the aggregator feature that we have in the MongoDB console. Let's copy the search syntax here. Let's find the aggregator, and you can go to here directly from the search tester, aggregation. Search performs a full text search on the specified fields. Let's see. And here I think we need the inner part of the search. maybe just this bit. Yeah, so as you can see, when I was trying with just the 3 letters in Ajax, it is not coming back with the results. It's because I'm doing a text search, and once I write the complete word, it brings back the results. So we're back to the same question: how do we make it work when we have partial text? And in order to do that, all we need to do is just replace this bit with autocomplete. And you can take this out. Path is required, and it does need a path, and the correct syntax to provide the path is something like this, where we tell it what field we need to search into, and also we can give it some additional options such as the fuzzy options. For full details of the available options, please feel free to check out the documentation. Here fuzzy max edits means that how many spelling mistakes we can tolerate in our search. So let's say we have this thing and it still returns me the correct result because we have Ajax. But what happens if I write S here? It should still come back with the results because we have fuzzy max edits to 1, and it is trying to take into account a mistake of 1 character. So, but as you can see here, uh, we are getting back a lot of data from our document, and when we are uh, typing into a type ahead control or an autocomplete search control, uh, it's just not a good idea to bring back all of this data because at that time we don't need all of that data. We just need to display the main field that we are searching for. And in order to limit uh, the amount of data that we are downloading from MongoDB, and there could be many reasons to limit that data. One of the main reasons is at the client side, you have to be very careful about the network that your application is using, about the amount of data that your application is downloading. So you don't know that if your client has a very good data connectivity or if they have a very good package on their end. So it's always best to be limiting the data that you make your clients download. So in order to do that, MongoDB provides this project syntax where we can limit the fields that we are returning back. And here, as you can see that I have written business name to 1, and out of these results, I'm getting only the business name and just the required ID. And if I need to get more details, then the client can take note of this ID, and then using that ID, it can obviously query the database. So let's just give it a try with another field and say I want the phone number as well. And if I write it like this, and you can see that we have the phone number as well. So that's it for this part. Now we'll move on to the next part where I will show you how I can implement this functionality in a cloud function, expose it through a REST API that we can use in any client that has access to the internet. Let's move on to the app services section. So as you can see that I have already created app services for my cluster. Basically, you can enable the app services for any cluster that you have in your account. And it gives you some basic functionality that you can use to query your database using RESTful APIs, and you can develop cloud functions on that as well to do complicated queries, or maybe you might have to do filtering before returning the data or do some business logic on that data. So in those kinds of situations, you would want to use that. And as you can see, for free tier, I have 1 million of requests available for this month. And because I'm just testing it, I have already used almost 1,000 requests. So in order to link your cluster to the application services, just create here. By default, I just have one cluster available because it's a free tier and it's already linked. I think I don't have to do, but I can still create another instance of app services on top of the same cluster. But I'm not going to click on that. I'll just cancel that, and instead I'll show you what I did to make my cloud function. From the left menu, you should be able to see functions among a bunch of other services, which includes GraphQL, triggers, HTTPS endpoints, which we're going to be using to link to our functions. And right now we're going to see the functions. So in order to create a function, I will just click on create new function. I have to give it a name, obviously. Oh. So we need to tell it how we want to authenticate to our function. I'll just leave it default for now. Let's just keep this default, and we'll see later on which of these things we will need. Save draft. Changes could not be saved, please. Resource name can only contain ASCII letters, so we have a problem here. Underscore, I think it should be happy now. Save draft. And as I saved the draft, it opened up the function editor and it created a default function for me. Let's see how we can use it for our autocomplete function. So this is the structure of a function which will accept the request, HTTP request, and will return HTTP response object. So the first thing that we need to do is we need to call our database, our application service. We need to get to that. Then we need to load our collection. The syntax for that is as shown. Once we have our collection, we need to write the aggregation query that we want to perform. The syntax for doing the search is like this. Here you can see we are making use of an index that we had already created earlier on. This was the index that I have created before recording this video, but it is exactly the same as as was demoed earlier on. And then again, we are using autocomplete. Then we are using the query, and the thing note down here is that I am getting the text from the query. Basically, this is the query string that I would have in my URL, and then the path on which we are doing the search, and then the same fuzzy thing that we explained earlier. We can limit the records. So here I am limiting the records to 10 only. Then we can use the project to return only the fields that we are interested in. I have given a sample of, but you don't have to return all of the fields. It's up to your use case. And then in order to call the aggregate function on the collection, we will pass the whole JSON object to the aggregate function, and then it will return a cursor on which we can call the toArray method to return the results. And then in the response, we can set our status to 200, and then we can set the results in our body and use json.stringify to set that result. So at this point, I think our function is good to go, and all we need to do is save this draft, save, and review draft and deploy. We can set a custom deployment name, but at this time I don't think I need a custom name. Deployment was successful. Now the fun part here is how we can link it to the endpoint. So here we add an endpoint. I'll just call search business. Let's put this here, and it will look like this. what HTTP method I want. I don't want post, I want get respond with result. I'm not sure what that means. We'll find out. JSON is fine. Let's select the function that we want to link it with, and let's save this as a draft. And then we can click on review draft and deploy. Deployment was successful. Let's just go and check the authentication section as well, what we have set over there. So as you can see, I have enabled the API keys, which would mean that any of the API that I enable will need a key to call that particular endpoint. So here you can add as many keys as you would like. I have already created my key and saved it. You can only see the key once, so make sure to keep a note of it somewhere safe. And I will try my API through Postman now. Okay, so I have created this Postman request. I have set the authorization, which is it's inheriting from the parent. And here we can see that I have set the API keys. And again, in the header section, you can see the API key is being set and the body is completely empty. We will just need to pass on the text field as because we were looking for that in our cloud function, and our endpoint was called search business. Let's save it and give it a try. There we go. We have some results back. Let's try Ajax. We have a bit more data for that particular string. There we go. Let's just see if we type something odd, and it comes back with an empty response. And also, just for fun, let's give it a try without any authorization and see what happens. And here we go. It's coming back with a 400 bad request, which is because we haven't provided it with any authentication method. Let's head over back to the MongoDB console. Refresh this page, and here we can see the logs of the HTTP calls, and we can see in real time that which endpoints are being invoked and also any errors that happened. So basically this was the case where I did not provide the authentication header. So now that we have our endpoint configured, we can integrate it with any application, whether it's a mobile application or a web application or it's a desktop application, anything that can make REST calls over the internet can easily integrate with this MongoDB without having the need to import the MongoDB SDKs. So it can be because the thing that we are working on does not have an SDK available, or it doesn't have enough memory to download and make use of the whole SDK, so we have to limit it to certain packages. It could be any number of reasons that we cannot use the regular MongoDB SDK. So in this way, if we can create a cloud function and expose it via an HTTPS endpoint, we should be able to use the functionality of MongoDB. That's it for this video. I hope you liked the video, and if you did, please give it a thumbs up, and I will see you in the next one. Thank you.